So hello and welcome. And my name is Andrei. I'm a full stack developer and I work a lot with Angular 1. And at some point I decided to, of course, have a look at Angular 2, as probably many other people. By the way, could you raise your hands, guys, who already tried something about Angular 2? Okay, pretty much everyone. So I guess you will find this kind of pretty familiar, because what I was expecting when I first started working with Angular 2 is something like that. So that I can just create my app component and then just drop a script into the page and put the code there. I was a little bit wrong, and actually if you go to the official site, to Angular 2 official site, and go through the quick start guide, which is called 5 minutes quick start, but well, it's so not really 5 minutes at coding time on top, but it's kind of 8 files, 8 different files, and more than 150 lines of code. Does it look like 150 lines of code? I don't think so. So it's a little bit big, you know, I think, for the hello world. And by the way, some other options to create your Angular 2 application, which is like Angular seeds, different and stuff like that. And for example, Angular CLI, when you do ng-new, it creates it creates a folder which weighs 300 megabytes. So it's pretty much a lot of stuff. And I decided, what is going on there? I need to know that. And so the purpose of this talk is basically to clarify what is in the boilerplate. Why do we need it? Do we need this at all? Maybe we can get rid of that. And I want to steal, my idea was that I want to create this minimum Angular 2 application, really minimum single file thing. And basically I did that. And I'm going to show you how to do that today. So that's the plan. Let's see what happens. So what is in the boilerplate? And it turns out, if especially if you take some Angular seed example or Angular CLI, there are a lot of things. It has HTTP server, it has everything. It has different testing frameworks, but if you remove all this unnecessary stuff and go really to the core, then there are 3 main parts. The model system, then utility libraries, and some TypeScript stuff. So let's talk a little bit about model system. So the current state of models in JavaScript is that they are in the standard, but they are not supported by the browsers. Funny thing is that the only browser that supports ECMAScript 2015 models, can you guess? Yeah, Microsoft Edge. Like, wow. Yeah, but anyways, this is not enough for kind of production application. So Angular 2 team had to use something, and they decided to use System.js. Well, there are many options. You can use Browserify, you can use whatever to bundle this stuff, Webpack, and even, well, I don't know, Babel includes the plugin for bundling stuff and so forth. But they decided to go with the dynamic model loader, so they can actually load stuff lazily. So basically, the page loads, and imagine it is a single page application. It is huge, and there are many models, different files, and so forth, we don't need to load them all at once, actually. And it is a huge amount of initialization time, and maybe user will never need them. So it kind of makes sense to use this dynamic loader that can load models dynamically. And System.js is actually quite good in the sense that it is sort of universal. I don't like that. One thing about System.js that you know, there are many model formats. There is AMD, CommonJS, and so forth. And then, but then there is also now System.js model format, which is bad. But anyways, it supports all the common model systems, including itself, and can transpile even on fly in browser ECMAScript 6 and Typescript. Well, if you configure the plugins, but well, being modular for model loader is okay, I guess. And then it can bundle this stuff, and also it is kind of a separate project, but again, it is just about modularity. So System.js Builder does that. So I'm just trying to make a point that this stuff is included with Angular 2. Angular 2 is working using System.js. It uses it for bundling, let's say for models, basically for making many files work as a single page. And well, maybe there is kind of a point to read about that if you are not familiar with System.js yet. Okay, and another interesting thing is that actually Angular 2, if you install the package from npm, it includes UMD models. And UMD stands for Universal Model, another universal model definition that supports CommonJS, AMD, and also it falls back to global objects if nothing found. Anyone knows, by the way, difference between CommonJS and AMD, for example? Can anyone tell this? No? Basically, CommonJS is something that what we use in Node. There is a conceptual difference between those. So, there you can write. There you write, for example, like this: require jQuery. So you write something like var jQuery equal to require jQuery. That's it, right? And this is asynchronous stuff because it doesn't have any callback. But there is AMD that stands for asynchronous model definition that actually has the callback. We use define for defining stuff there, and actually, by the way, it's very similar to how we do. We define, for example, controllers in Angular 1. So pretty much the same. You first declare dependencies and then provide the function. And this is asynchronous by nature. So universal model format is very ugly. It actually, this is code from this universal model format file. It is a wrapper code that is included with every file, and what it does, it tries to determine if currently on this page some model loader is available, and if there is AMD model loader available, then it uses AMD. If not, if there is a CommonJS model loader, then it uses CommonJS. And then it falls back to the global objects if nothing found. And this is pretty useful because basically I can, my idea is to create it like, single file. I don't need really models. And so I can use this for, since Angular 2 has UMD models, we can get them from CDN, and then we can use them because they fall back to the global objects, and use them exactly as global objects. So that's it for the model system. And let's move on to the utility libraries. Okay. And there are 3 main utility libraries in AngularJS that we cannot get rid of at all. So there are, for example, they also usually include browser schemes for supporting all the browsers and maybe some other stuff. But there are 3 essential libraries that are included, and Angular itself depends on them, and it cannot work without them. So these are Zone.js, RxJS, and Reflect Metadata. Zone.js and Reflect Metadata, they are very simple libraries that do some simple job, but RxJS is rather big, and I don't want to talk about RxJS in this talk. It's kind of outside of the scope, really, because well, but anyways, you can obviously Google if you are not familiar with RxJS yet. Yeah, so let's go to Zone.js. So maybe you heard about that already, and Zone.js essentially does what it does. It tracks asynchronous code, and basically what it does, it solves the scope apply problem. So in Angular 1, we had to do something like $timeout. Or if we needed the event listener, then we would do scope $on and then create an event listener. Why we should do that? Because otherwise Angular will not update the view after we process some we do, for example, some event processing. So we would have to do scope apply for that in order to do that. But and that's why all those wrappers, so $timeout would just basically call your function and then call scope apply. That's it. And scope apply calls scope digest. And this will run the change detection and so forth. So in Angular 2, it's fully automatic. And here's some code. It looks a little bit scary. I agree, but well, it's actually rather simple. So first, I'm using fork. This creates a new zone, and then I can run some code in this zone. And then I can also configure the zone. And there's onInvoke task handler that defines that every time some task, and task is some asynchronous operation, every time some task is called, then we can do our stuff. And the task itself is available, and task.callback refers to the original function that kind of should be called, and then we can put our own code after that. And so then we can run kind of this zone is sort of an execution context, and we can run our code inside. And even though I'm using just normal set timeout here, normal add event listener, everything, and I'm not calling this scope apply here, but this will still be called after kind of, for example, if we see the timer message in the console, then we will see scope apply message in the console. And let me demonstrate that. So I'm opening the console, something like that. And then we see timer, and then we see scope apply. And also we set the event listener to click. So whenever I click somewhere in the presentation, it will. So I clicked 3 times, and then you can see that there are there are 3 clicks in the console, and after each of those, we had this code scope apply. So basically, it solves this scope apply problem, but maybe it can also be used for some funny stuff, for some interesting stuff. And it is interesting. Also, interesting thing about Zone is how they process errors. So if some error is thrown during the execution inside Zone anywhere in asynchronous code or in synchronous code, doesn't matter, they kind of rewrite the stack trace. So that in stack trace they add all the asynchronous operations that were there, and that makes debugging asynchronous code really interesting, really simple. And probably when you stumble upon Angular to some errors, then you will see that the code is can be actually asynchronous, but still you will see all the stack trace. So this is what Zone does. All right. So then we have, RxJS, and this is about asynchronous data streams, functional reactive programming, and this is outside of this presentation. But yeah, you can look it up. And then we have reflect metadata, very simple library that can, basically what it does, it can associate some arbitrary data with some arbitrary JavaScript object or property. So you can provide target object and then property key, and then it's going to be associated with the property. So basically when we do decorators component, essentially what happens is that some metadata gets assigned to our class. That's it. And then we can get this metadata later. So for example, selector or template is the example of the metadata. And this is how Angular works with those decorators. Basically, every time the decorator is running, then they do some reflect metadata call, usually. Okay. And that was all for utility functions. And now let's go quickly through the TypeScript stuff. This is my favorite topic, so I can talk a lot about that, but basically TypeScript here is one thing that we really can get rid of. It is completely optional, but I would strongly advise against that, because TypeScript provides, in case you have a big solution, then TypeScript is just essential, I think. And it is about great navigation experience through the code. It is about great tooling, IntelliSense, and type system itself is also quite flexible, and so forth. And by the way, about the IntelliSense, if you want to get good IntelliSense against the external libraries, then basically there's a rule of thumb that you need these typings also. So typings is just a collection of TypeScript definitions for different libraries. So basically every time you install a new library, add a new library to the project, you run something like npm install library name, then what you want to do is after that run typings install library name, and usually it solves all the problems. So this is why typings is there, in case someone wondered. So that's it for the boilerplate, basically. I mean, well, it's not so much stuff, it turns out, and probably some of this stuff can be even useful. So we return to the question, do we need it? Well, we don't really have much choice, and probably we do need the model system anyways, because if we are not creating really hello world application, then we're gonna work with many files. We need to structure our application, and so we need model system. And utility libraries are used by Angular itself. So if we are not using them, well, nothing bad happens. But if we are using them, then we kind of benefiting from something that was already there. So why not? And now let me show you how to create a minimal Angular 2 application. So basically, by trial and error, I compile this this list of eight different scripts that should be deployed to the page. So they can be, of course, bundled, but good thing about those is that they can be used via a CDN, and you don't need to load to bundle anything yourself. So there are those free libraries that are utility libraries, okay, and then there is a bunch of Angular stuff, including core, and then common, and then compiler, and platform browser, and platform browser dynamic. Anyone knows about what is the difference and why the heck we have this platform browser and then platform browser dynamic? Anyone? No, really? Nobody knows about that? Really? Okay. So basically, the story is that that in Angular 1, we had templates that we had only kind of one option out of the box, at least, that templates are compiled in browser. So they are loaded in their initial form of HTML stuff, and then Angular compiles those templates, turning them into some JavaScript code. This is actually what happened. Now, we have this ability to compile templates offline. What that gives us is that this compiler.js is no longer needed in browser. So kind of compilation already happened offline. So Angular 2 tries to move as much as possible to compile time. And before that, we could only like minify stuff offline and then deploy it to production. That's it. Now we have offline template compilation. We have this TypeScript transpilation and so forth and so forth. So a lot of stuff moved to their kind of compile time, and then this platform browser dynamic is basically the bootstrap for compiling templates online, so in browser. And if we compile templates already, then we don't need it. So we can compile templates offline, deploy the resulting code to production, and then we don't need this, and we don't need this. This is interesting. And it actually can kind of reduce considerably the amount of code that has to be deployed to production. Okay, so actually Angular 2, although it is rather big, but they have this tree shaking using Rollup GS. They have this offline template compilation. They are pretty small if you think about it, if you do it right. Okay, but let me show how to create actually this minimal Angular 2 application, right? So now I want to switch to Visual Code and just create a let's say minimal.html file, and let's create this file HTML and then add body, and then add all those scripts. And of course, we need to wrap them into scripts. I feel so powerful when I do that. It's like having many hands, you know. Yeah, it's called multiple cursors, in case somebody doesn't know that. Supported by Visual Studio Code at least, but I guess by many other editors as well. And for example, in Visual Studio Code, you can just place the cursor actually in any place and just press Alt and then click, and then we have two cursors and they work simultaneously. This is pretty neat stuff. Okay, but so my initial idea was that we have a bunch of TypeScript code here. We have the single tag for my app. Oops. Yep. And then we have this component and so forth. So this is just ordinary stuff, and then class app component. And we have selector, obviously, that's gonna point to my app, and then template. And we can write something like, I don't know, hello Angular meetup people, or something like that. All right, but then, of course, this code will not work. And why is that? Because we have TypeScript, so it's of course not supported by the browser. So what do we do? And well, it's actually pretty simple to compile TypeScript in browser. Anyone knows how to do that? It's probably 3 lines of code. So if I just add a TypeScript here, then I add another script, and basically here we have, let's transpile this code, ts.transpile, and then you pass any string there and it transpiles it. So we need to do something like document query selector, and then type equal ts, so referring this element. And then we of course need inner HTML of that. And then if we evaluate this code, now this should work. But there is one more thing. So basically we have component, but there is no component in global namespace, because in this Angular UMD models they use namespacing. So for example, for this Angular.core, it's gonna be ng.core and then .component. So let's fix that. ng.core. And then, by the way, we need also to bootstrap. And the bootstrap is, since we want to compile the templates, obviously client side in the browser, then we need this platform browser dynamic, but we need, of course, to camel case it. Eek. Oops. All right, so now let's camel case it. And of course, we need to bootstrap this up component. And this is, by the way, the essential kind of the minimal configuration, and probably, well, we can make it even better. We can get rid of those ng platform browser dynamic and ng core. I will shortly. But let's run this one first. Maybe it doesn't work. I don't know. So it is in the demo folder. Oh, actually, let's run it in Chrome. And it doesn't work. Oh, all right. Yes, I can see. But by the way, this was quite nice error message. Like it's quite clear what happens. And they are doing some efforts towards the making error messages good in Angular 2, which is good thing, really. Although sometimes you know there are still errors that are not really clear what is happening. But yeah, it works. So we can actually get rid of those as well. Well, it might require some ugly hacking, but well, we can do this. So well, let's do it actually. Oops. Just to show you the concept. So I'm just a perfectionist, and I need to make it work perfectly as I want it. So we're gonna need imports here from Angular core, and then we're gonna need import bootstrap from this ugly and long stuff. Oops. Yeah, and now, but let's first, before evaluating this code, obviously it will not work because we don't have any model system in here deployed. And if we deploy a model system here, it's kind of going to be quite bad, I would say, because then we have a lot of boilerplate. Maybe it's still possible, I don't know, to do, but I haven't figured out a good way to do that, let's say. Okay, but let's just put this code into the console and just see what is generated. And of course we don't see anything here, but in the console I guess it's pretty visible, probably. Well, but basically we need those two lines. This is what our imports just turned into requires, basically. So if we could replace this require with something like ng.core and here with ng.platform browser dynamic, then we could actually solve that problem. Yeah, and this is another 3 lines of code. So we need to create our own require function, and it has a string. Yeah, this is gonna be probably a little bit boring, but bear with me just a little bit. Okay, and we need to replace all those things, slashes to dots, then replace all Angular to ng, and then we're gonna camel case this. I don't know what is the right way to do camel case from this dash notation. I guess it's pretty common task in JavaScript, but I do I usually do it like this. So, oops. So so dash and then a letter going to be replaced to this is all on, and this is group, and then group to uppercase, and that's it. And now if we return eval as, then we can actually evaluate this code and it's gonna work, I guess. No. Yeah. One small stuff. You know, there was a joke about that. My favorite speaker, like, he says, I never understand these regex people. They are writing something like, and, oh, it doesn't work. Yeah. Yeah. Oh, yeah, now it works. No, because it's regex people, sorry. Yeah, okay, but now it's gonna work, yes. And if we dive a little bit deeper, no, but I will not write this code anymore. Let's just replace. This is basically the same code, but I just added. I just, instead of the script tag, we are now using text area, okay? And then I wrap this text area into code mirror, which is online editor, and then every time this editor is changed, then we evaluate the TypeScript again. And so this means that we have now live editing experience, which is really nice, you know. So yeah, so actually it is pretty much possible to create this kind of stuff in AngularJS using these UMD models, but for me it was really surprising that there were any examples nowhere in Google anywhere of doing something that simple. But of course, there is a lot of sense in the way how they do it. So they are having a lot of boilerplate there, right? But Angular 2 is supposed for real-world applications. It is supposed for big applications that need model system, that need all the bunch of hopefully you now know a little bit more and will feel a little bit more confident with Angular.
There isn't anybody, then as usual I will have to talk something more, so probably it would be a better idea for somebody else also to come there. And if you have any hobby project or what you have learned on the works, you can come with that to the open stage. But come to me if you have anything.